Okay, let's do this together, right? I try to cover what we did last class. Look at number one, right? Number one. If you see the E variant, it will be better, right? You can see the color. But when I printed the printer, there is no color printer. So, but find the equation on the line. F is the line, right? Very clear. F is the line. So how do you find it? You already know 2 points, right? I already labeled 2 points on the line, like this point and this point, right? 0, -1, 3, 5. And 0, -1, it is the y-intercepts, right? It's the y-intercepts, right? So you're gonna know this if you want to find the line by using this form f of x equal to mx plus b. If you're gonna use this form, then you already know b, right? You already know b. B is -1. So you only need to know m, right? You only need to know m. And m is the slope, so use the slope point form, which is y2 minus y1 over x2 minus x1, all y1 minus y2 over x1 minus x2, right? But anyway, you know those 2 points, 0, -1, and 3, 5. You can also use the other points, right? You can also use the other points, but those 2 points already labeled very clear. So those 2 points may be better. So you can see what is this point? This point is not an integer, right? Which point is integer? This point is integer, right? This point is the integer, so here's 1, 1, right? You can also use this point. But for me, I'm gonna use those 2 points since it's labeled and clear. So y2, we're gonna use 5 minus y1 -1. And x2, 3 minus x1, 0. So you get 6 over 3, which is 2. So the slope is 2. And f of x equal to 2x minus 1. And some of you guys use rise over run, right? Rise over run. That's good. That's good. Rise over run actually is this formula, right? Rise over run is this formula. But I see some of you got to draw a graph like this, right? Someone draw a triangle like this, then find this is 2, this is 1. So you get a slope. It is 2, it is 2. Very good. And somebody draw a bigger triangle like this, right? Like this. And you find the length. This one, the length gonna be, this is the 4, right? And here's 2. And 2 over, 4 over 2 you get. Very good. But this is the linear, so it's very easy, right? Very easy. Second one, find the equation of the parabola, right? Find the equation of parabola, very good. Many of us use the vertex form. That's very good. So if you use the vertex form, the vertex form is like this: a times x minus 2 squared. That's not. Here's minus h squared plus k. So some of you guys forget a, right? Some of you guys forget a. So just assume it's x minus h squared plus k. But you should have a coefficient here, all right? Have a coefficient here. And then you plug the vertex, which is 1, -3, right? Vertex, which is 1, -3. So you plug 1, -3. That means the h 1, -3. That means the h is 1 and k is -3, right? So you have here x minus 1 squared, and k is -3 minus 3. Right. So you get this form, right? You get this form, but you need to find a, right? You need to find a. What should you do? You can use another point, right? Use another point on the problem. So I'm gonna use these points again. I'm gonna use 3 and 5 again, since this point is labeled very clear, right? So we're gonna use these points. So you plug 3 and 5 inside. That means you let x equal to 3 and y equal to 5. So here we don't have y. That means the g of x equal to 5, right? To find this equation, we're gonna have 5 equal to a times x minus 3. Sorry. 3 is x, right? X is 3. Minus 1 squared, then minus 3. So here you get both sides plus 3, you get 8 equal to a times. Here 3 minus 1, 2. And 2 squared is 4. So you get a is 2, right? You get a equal to 2. Both are divided by 4. You get a equal to 2. And then you plug a into this function. You will get g of x equal to 2 times x minus 1 squared minus 3. Alright, now it's done. You see CDE, right? CDE, you see, I kind of give you guys a reminder from the graph. You see, find this from the graph, find this from the graph. There's some students use do it algebraically. Since you already find the function, right? We already found the function f of x equal to 2x minus 1 and g of x equal to what? This one, some of you guys convert it to the general form, so you get 2x squared minus 2x, and then what is that? Minus 1? Let me see, what is it? Something x squared minus 2x plus 1, then times 2. So you get this. Oh, here's 4x. So 2 times this 2x squared minus 4x plus 2 minus 3 minus 1. Right? So some of you guys just use the geometric form. Use the algebraic form to do it. Some of you like f of 0. Some of you guys find f of 0 from this equation, and you get -1, and then find g of 0 from this equation. You get what is that? G of 0, which is 2 minus 3 -1. So and then f of 0 times g of 0, you get -1 times -1, which is 1. This is good. This is not bad, but you need to spend more time on this if you use the algebraic way. Do you guys know what I'm talking here? Like some students use the algebraic. You don't. You just use a graph, right? F of g. This one. It means f of 0 times g of 0, right? This is f of 0 times g of 0. So f of 0, you can find the value from the graph. F of 0 is -1, right? From the graph, look at the graph, right? F of 0 is -1. G of 0 is also -1, right? G of 0 is also -1. So here, you know, it's -1 times -1 equal to 1, right? Equal to 1. And the second one, f over g of 1 is equal to f of 1 over g of 1. To find what is f of 1, f of 1 at this point, 1, 1, right? 1, 1. So function value is 1. G of 1, use the graph again. G of 1, -3, right? -3. So -1/3. And f plus g over 3, it is f over 3 over g of, not over, this is plus g over 3, right? Plus g over 3. Again, use the graph, right? Use the graph. F of 3 is what? Both of them have same value. F of 3 is 5. G of 3 is also 5. So here's 5 plus 5 equal to 10. And last one, f minus g of 0 equal to f of 0 minus g of 0. F of 0 we already know, right? -1. And g of 0 is what? Also -1, right? So here you get 0. Right? Anything wrong? Yeah, maybe I'm gonna make a mistake. I just created the question, but I didn't do it. Last time when I was checking, I just checked roughly. So, and the D, right? You see, C is the combination function, like a sum, difference, product, quotient of two functions, right? But E is, this circle is different, right? It's not mean the product. It's a composite function, right? Composite functions. So the first one, the composition of J and F. So this one, J circle F of 0, they're gonna equal to J of F of 0, right? J of F of 0. So you can find f of 0 first. From last question, we already know f of 0 is -1. So here become find J of -1, right? J of -1. J of -1, then from the graph, right? From the graph, you just read it. J of -1 is what? J of -1 is what? It's this point. J of -1 is 5, right? It's 5. You see here, maybe you can draw a graph. There's a try to erase this one, but cannot be erased. You can find the line of symmetry, right? Axis of symmetry is x equal to 1, right? X equal to 1. So you see -1 and 3, right? -1 and 3 is symmetric with x equal to 1. So this point, you see -1, 5, and 3, 5, they are symmetric about the line, right? So you know f of J of -1, it will be 5. F circle J of 0, this one, write the definition first, it is equal to f over J of 0. J of 0, you already know it. It is -1, right? Or you can read it from the graph. So f of -1 is what? Check the graph. F of -1. F over -1 is here. So -3, right? -3. So you get it. Find solution f greater than or equal to g. F greater than or equal to g, that means the line greater than the parabola, right? Line greater than the parabola. It is this part, right? It's this part. You know, on this part, line is greater than parabola, right? And then you need to find the x value. X here is 0, and this point is 3. So from 0 to 3, f of x is greater than g of x. So you just write the interval. Since here, right, have an equal sign, so you're gonna use a brackets. Right, this one is very easy. Okay, 2. You know, last class I give you extra credit, right? So you should do the easier one. I can do number 2, right? Number 2 is very easy. So, but some students still make a mistake on this one. So, like what I said, you see 0, right? You should use this point first, right? Use this point first. If you see this one. Since this one, it will give you f, you're gonna let f of x equal to 10, right? And x equal to 0. So you will get 10 equal to c times a to 0. A to 0 is what? Is 1. So it just equal to c. So from this point, you can find c, right? You can find c. After you find c, the function become f of x equal to 10 times ax. You already find c, right? You already find c equal to 10, so do not use c anymore. Just substitute 10 for c. And then you just need one extra point. Any points you want, right? But you need the other 4 points. So let's use 1 and 5. That means you let the function value equal to 1. So use 1 and 5. Let the function value equal to 5, and let the x equal to 1. Right? X equal to 1. So here both are divided by 10. You get a is 1/2. A is 1/2. And then you plug a into the function. You will find f of x equal to 10 times 1/2. Right? 10 times 1/2. And I see some of you guys make this mistake, like 10 times 1/2. Sorry. This is very funny for me, so I have to laugh. So you get 5 to x. This is wrong. This is very wrong. But you make this kind of mistake, that makes sense. Since 10 times 1/2 is 5. But the thing is, you cannot use 10 times 1/2 here. Right? You need to do this one first. You remember the order of operations, right? Order of operations 1/2 2x. You need to do this power first. Alright? And you need to do this power first. Alright? You see the process here. Then after you finish this, then times 10. Alright? Then times 10. Then times 10. For example, right? For example, if we use 1/2. For example, we let x equal to 2, right? Let x equal to 2. You need to calculate this first. It's 1/4, right? 1/4. So 10 times 1/4 equal to what? 10/4. 5/2 or 2.5, right? Or 2.5. But if you follow that way, you 10 times 1/2 first, and then square, right? If you do that way, 10 times 1/2 first, then square, you're gonna get a 5 square of 25. You see, the two values gonna be different, and one of them is wrong. This one is wrong. You need to do this one first. All right. How did you know that you was 0 to 10? How do I know? That's a good point. Because we did this question before. When you are doing the first time you do this, right? You're gonna choose points randomly. But after you do this, you gain some experience. You're gonna using 0 first, using the point has 0 first.
So choose the point that has 0 on it, because if you want the point that says 0 and then your y is like 5, your speed is going to be 5 automatically. That's why.
Yeah. Again, you don't have to choose this point. You can use any point, any 2 points, right? For example, if you lose 2 points, you just plug x equal to 5 and the function value equal to 5 and x equal to 1. You will get 5 equal to c times a to the first. This one you will get 2.5 equals c times a squared. This is what? System equations, right? System equations. You can just use equation 2 divided by equation 1. You will get a is 1/2.
So you know what the answer has to be in this case, we already know the answer.
You know the answer is 1/2 because what? Because the function value is going down.
In the y value, it goes from 40 and it splits in half to 20. Splits in half to 10.
Yeah. You can find like 20 divided by 40. 20 divided by 40 is 1/2. And 10 divided by 20 is 1/2. 5 divided by 10 is 1/2. 2.5 divided by 5 is 1/2. If you can find 1/2 through this way, that's very good. Because this one is a geometric series. And the common ratio is 1/2. Geometric series. Common ratio is 1/2, but we didn't cover that, so that I didn't use this method. Some of you guys use that method, is very good. But this one, I think for us, since we learn system equations, you can just get system equations all through 0 10 to find c, then use another point to find the a, which is just use linear. Just do the linear equations. Good. But don't make this mistake, right? Don't make this mistake. You follow the order of operations. We need to do the parentheses first. If you have the parentheses, right? Do the exponent, right? Do the exponent first. Products quotient and then some difference, right? Number 3, find the domain. This question is a very good question, right? Find the domain. We need to find the domain, and you see number 1, right? Number 1, find the domain. when we try to find the domain, we need to solve quadratic equation, right? Quadratic equation. So you need to solve this equation, right? You need to solve this equation, and solve this equation is a very simple one. So we can just use factoring, right? Just factoring. And then you get x equal to 1 and x equal to 2, right? X equal to 2. So now you can write the domain, right? The domain gonna be negative infinity to 1, union 1 to 2, then union 2 to infinity, right? To the infinity. This is log, right? Logarithmic function. So you should make sure x squared minus 1 greater than 0. Here's greater than 0, right? Not greater than or equal to. Then this one is a quadratic inequality, right? Quadratic inequality. When it's greater than, you can write like this: x greater than 1, right? X greater than 1. So x greater than 1, that means x greater than 1 or less than negative 1, right? Or less than negative 1. So you can either do this way or factor it: x plus 1, x minus 1, right? That means this greater than 0. So you let this guy equal to 0, you will find two values. One is a negative 1, the other is 1, right? But it's greater than 0, you should pick those two parts. If it's less than, you pick the middle parts. So here, from negative infinity to negative 1, union 1 to infinity. So quadratic inequality, this is quadratic inequality. C is a little bit annoying, right? A little bit annoying, but you can use testing in the interval. Find all the zeros on this one, right? Find all the zeros on this one. But you should make sure the inside should be greater than or equal to 0, right? The inside is greater than or equal to 0. So you find all zeros. This guy gives you negative. This guy gives you negative 5. Here you find 5, and then here you get 1. This guy gives you 0 is square root 2, right? So you plug all those numbers on the number line. Negative 5, and then 1, and then 5. Okay, square root 2 is greater than 1, so square root 2 should be here. But since this inequality is greater than or equal to 0, so you should use dots, right? Dots for those points. Right? Dots for these points. And this one, you see this one, you should use a circle, right? Since you cannot 1, negative 1. 1, negative 1 will be not in the solution. But this one, all of the values will be in the solution. Negative 5, 1, negative square root 2, and 5. And then you test the what? Test the intervals, right? Test the intervals. You're gonna find let's say negative 6. You test negative 6 here. Let me change the color. This one we choose negative 6. You put negative 6 inside, you will have negative 6 plus 5, negative 1. And negative 6 minus 5, negative 11, negative 6 minus 1, negative 7. And this one is always non-negative, so you can just ignore that one. And you find that here it's less than 0, so you should not use this interval. And then negative 5 to 1, we can choose 0, right? You can choose 0. Choose 0 for negative 5 and 1. You put a 0 inside, here the 5, here the negative 5. And here negative 1, so it's positive, greater than 0, so this part is good. So you can write negative 5 to 1 is good, right? Negative 5 to 1. And then some of you guys look at this as another interval. We can write the intervals, right? So negative, write the intervals first, negative infinity to negative 5. And then union, not the union, negative 5 to 1. Right? And then 1 to negative 2, and the negative, 1 to square root 2, square root 2 to 5, and the 5 to infinity, 5 to infinity. But this one, those two, you can just look 1 to 5 at one interval. All right, look 1 to 5 at one interval, 1 to 5. Why? Because square root 2 is just 1 point, right? Just 1 point. This guy, square root 2 does not affect its negative or negative or positive, since always greater than equal to 0. But this one gonna tells you square root 2 is a solution, right? So when you figure out a solution, do not forget to put square root 2 into the solution. So 1 and 5, let's check 2. Let's check 2. From 1 and 5, you're gonna have 7 times negative 3 and times 1. So you know this is less than 0, right? Less than 0. So this part is not solution, but square root 2 is a solution, right? Square root 2 is a solution. Then check the last one. You will find the last one will be solution also. So we can check 6. So here you have 11 times 1 and 6 minus 1, 5. So always greater than 0. So 5 to infinity is also a solution. But do not forget square root 2. Square root 2 is 1 point, so you should use brackets. It's gonna be your solution. So I see many of you guys almost find the correct answer, just forget square root 2. Just ignore this, right? Do not forget it. Since look at here, right? Look at here. Okay. Now number 4. Find the zeros. Find the zeros. So you see here, this guy give you 0, negative 1, right? You let f of x equal 0. This one, you're finding negative 1 with multiplicity 2, right? This 0, 1 with multiplicity 2. And this guy give you a 0, which is 3 with multiplicity 5, right? Multiplicity 5. And this guy, you let this guy equal to 0, you will find x squared minus 5 equal to 0. So you get x squared equal to 5. So you get x equal to plus or minus square root 5, right? This is extracting the square root, right? Extracting square root. And then you let x squared minus 2x plus 4 equal to 0. This one, you're going to have an imaginary 0, right? Imaginary 0. So how do you solve this one? This one cannot be factored. So you can use a completing square or the quadratic formula. Here you're gonna use a completing square since it's very easy to use a completing square. Plus 3 equal to 0. So I split 4 into 1 plus 3, right? But now this guy will become perfect square. So x minus 1 squared and plus 3 equal to 0. Then both sides minus 3. You will get x squared equal to negative 3. Alright, now we can use the extracting square root. X minus 1 gonna equal to plus or minus square root negative 3. And square root negative 3 is what? The imaginary number is gonna be equal to square 3i. Maybe I should write like this: I times square root 3. So now x gonna equal to 1 plus or minus I square root 3. Multiplicity, all of those two multiplicity is 1, right? Multiplicity is 1. Why we ask multiplicity, right? Because I want to create a rough sketch for the function. When you create the rough sketch, you need to use the multiplicity, right? You need to use the multiplicity. And those two values are imaginary, right? Imaginary numbers. So those two will not show on the graph. When you draw the graph, find all the real zeros, put all the real zeros, you have what are all the real zeros? Negative 1, negative square root 5. Put it in the order. So negative square root 5, negative 1, and then square root 5, then 3, right? Those are all the real numbers. Multiplicity, this one multiplicity is 1, the negative 1 multiplicity 2, square root 5 multiplicity 1, and 3 multiplicity 5. Here are the multiplicities. You remember for the multiplicity, when the multiplicity is odd, the graph gonna go across that point. When the multiplicity is even, the graph touch that point then bounce back. We plug those values into the graph. So this is a negative square root of 5, negative 1, square root of 5. Yeah. Square root of 5 is a number close to 2. Alright, so here, and then we have what? We have 3. Okay, 3. So 3. Those are the zeros, right? Zeros. This is multiplicity 1, multiplicity 1. The negative 1 is multiplicity 2. Multiplicity 2 and 3 multiplicity 5. Just take a note. Then you can erase it later after you finish graph. And this one overall, the degree, what's the degree of this guy? What's the degree of f? 2? What's the degree of f? Not 2. Degree of this function equal to 1. Mm-hmm. 9? Is it 9? No, 9. 11. Look, this guy, let me use another color. This guy, the degree is what? 2, right? This guy, the degree is what? 5. 2 plus 5, 7. This guy, the degree is 2. 7. 7 plus 2 is 9. This guy degree is what? 2. 9 plus 2, 11. So the degree of this polynomial is 11. And when we sketch the graph, you need to use the end behavior test. So this guy, the degree is 11, so its end behavior should be similar to x cubed, right? And you know the leading coefficient for this guy, the leading coefficient, it is 1. Can you see that? It is 1. Since you see coefficient here is 1, coefficient here is 1, coefficient here is 1, coefficient here is 1. So you time together, 4 ones time together, it is 1. Alright, the leading coefficient is 1. So this guy, anyway, the leading coefficient is positive. So gonna have same end behavior as x cubed. So you're gonna here rise to the left, rise to the right, and falls to the left, right? Falls to the left. Alright, now you can sketch the graph. Roughly sketch, right? So here you're the graph gonna pass this point since the multiplicity of this guy is 1. And then touch here, you're gonna bounce back, right? Why? Because here the degree is 2. And then go somewhere, it's gonna go back since it's gonna pass this point, right? Pass this point. Right? And then this guy, the multiplicity is 5. So it's gonna go back and pass it, then go like this. Alright. So if you get graph like this, it will be right. You can get something like this, right? Maybe you get different, a little bit different, but here like this, right? Maybe go taller and then go back, and then maybe something like this, right? Here maybe like this. Then it will be right also, the brown one right also, right? You just want to know, if you know when the multiplicity is 2 like this point, you should touch it and then bounce back. Those 3, right? Those 3, it should pass it, right? It should pass it. And the end behavior. Right? Roughly sketch, right? Roughly sketch. Okay, number 5. Find the domain. Find the domain whole vertical asymptote, horizontal asymptote, x-intercept, y-intercept, and then sketch the graph. Show your work. This one, find the domain. You need let this guy, let the denominator equal to 0, right? Let the denominator equal to 0. Then solve it. You will get x minus 3 times x plus 2 equal to 0. So you get x equal to 3 and x equal negative 2. So now you find the domain is from negative infinity to negative 2, union negative 2 to 3, and then union 3 to infinity. This one is similar to this question, right? Similar to 3a. Find the domain. Okay, we already know the domain, and then we need to find the whole. How do you find the whole? You need to let the factor the rational function. So x minus 3 times x plus 2. This is the factorization of denominator, and the factorization of the numerator will be 2x. Here's minus 1, and here x plus 2. This is factorization. And then you see x plus 2 and x plus 2 can be cancelled. That means at x equal to negative 2, right? You will have the whole. Right? At x equal to negative 2, you will have the whole. And then you plug negative 2 into the function, into the simplified function. This is a simplified function, right? It equals 2x minus 1 and x minus 3. You plug this into the function, all right? So you find f of negative 2 equal to 2 times negative 2 minus 1 over negative 2 minus 3. So here 2 times negative 2 minus 1, negative 5. The denominator also negative 5, so it is 1. So you're going to have the whole is negative 2 and 1. Asymptote, right? Asymptote, you need the vertical asymptote, you need to use a simplified form. So the vertical asymptote gonna be x equal to 3. Horizontal asymptote, you need to compare the degree of the numerator and the denominator, right? They have the same degree, so horizontal asymptote gonna equal to the ratio, of the leading coefficient. And the x-intercept, that means you let the function equal to 0, right? Let function equal to 0. Let this function, let the simplified one equal to 0. So you get 2x minus 1 equal to 0. You get x equal to 1/2. So x-intercept is 1/2 0. And the y-intercept, you're gonna let x equal to 0, right? Let x equal to 0. Then you plug x into the simplified form. You will have it's 1/3, so 0, 1/3. And now you have so much information, right? Then you can sketch the graph. X equal to 3 is a vertical asymptote. X equals 3 is a vertical asymptote. And the y equal to 2 is a horizontal asymptote. And you know the x-intercept is 1/2 0. And the y-intercept is 0, 1/3. 0, 1/3. So looks like the graph have to be like this. Right? Have to be like this. And then you use some extra points, you will get it.
How did you find that the horizontal asymptote was 2 again?
This is because look at the graph, look at the function. This one, 2x minus 1 over x minus 3. This is simplified form, right? This one you need to look their degree. The degree of the numerator is 1. You get it? So here you can try the other point. But one point we cannot ignore -2 and 1, right? -2 and 1. This point, it is a circle, right? So you should make sure it is circle. Alright, the graph gonna looks like this. Right? You can try the other point. You can put more points. Right? Like x equal to 1, where you have x equal to 1, you're gonna have x equal to 1 over -2. So it's around here, right? Then use the other points. But if you get shape like this and you have the whole and the asymptote right, then you're gonna get all the points. Okay. Then number 6. This one, the model is very simple. You just let A, which is the current price of the car. Then times the principal, which is the initial price. Then 1 minus since this is the depreciation, so minus this to the t. T is the year, right? This one you are using this formula, compounding, right, n times per year. So A equal to P1 plus R over N and then times NT, right? But here N equal to 1 since annually. And the depreciation, that's why you put a negative sign, all right? Depreciation. And this one gonna you just when was half of the original price, so you're gonna let A equal to 5,000. Then both sides divide by 5,000. So this guy we can simplify it. 1 minus 0.8%, it become 0.92, right? 0.92 T. So here simplify both sides divide by 5. Both sides divide by 10K, you will get 1/2. Here 0.92 T, right? 1/2 is 0.5, right? 0.5, we can use 0.5. Then apply ln to both sides, you will get ln 0.92 to the t's. Then use the power rule, move t in front of it. So t ln 0.92. Then you will get t equal to ln 0.5 divided by ln 0.92, right? 1.92. Very good. This guy is around 8, right? Around 8. Since here keep the whole number, the nearest whole number. They ask you, right? Nearest whole number. Okay. Number 12. You better let use the year 2004, right? And 2007. You can let t equal to 4, right? And t equal to 7. Or let 2004 t equal to 0, right? T equal to 0. But do not use t as 2004 and 2007. So we can let right. I see most of you guys let this year corresponding to when, right? Like when is 2004, you're gonna let t equal to 0, and 2007, then you're gonna let t equal to 3, right? I think many of you guys do this. Now you get 2 points, 3, 4. So 0, you're gonna have 3, 4, 8, 3. And when it's 3, you're gonna get 4, 0, 5, 6. Then you're gonna get the, let's use A, right? The price gonna equal to MT, right? M times T. Then plus the plus B, right? Plus B. And here B, you already get it. It's 3, 4, 8, 3. So 3, 4, 8, 3. Now you only need to find M. Find M, you can use those 2 points. So 4 over 56 minus 3, 4, 8, 3 divided by 3. 191, right? 191. So here you get 191t plus 3483. So this guy, when how many storage will have in 2015? Here you go, you 2015 minus 2004, you will get t is 11, right? T11. So you plug t equal to 11 inside, m times 11 plus this number. So what is value? Anybody? I forgot what this value. Mika, what is this value?
5,584.
Yeah, this is the answer. And last one, you're gonna let 1,000 equal to m. M we already get it, right? Equal to 191t plus 3483. Then you will find the t for this value. T will be 34, right? 34. And 34 plus 2004, you will get 2038, right? In this year. Okay, do the part 2, right? Do part 2. Okay, have a good day.